Hello, good afternoon, and welcome to everyone. We are so happy to have you again with us this Thursday for a new episode of L-DIH Talks. Today is the episode number 8 of our series, which kickstarts the fourth and last section of these talks. This section is about how to build an open, interconnected, and innovative factory. Actually, it will address two topics. The first one is what are the latest technology to extract data in order to become a digital factory. And the next topic is what to do with these data. Today, we will start with the first one, with the first part, which is related indeed to the use of technologies such as IoT, AI, VR, AR, and others to bring your factory or your digital factory to the next level. For this, we are happy to welcome our guest speakers. So Conrad Gros from FANUC Europe, Mathieu Deboeuf-Rouchon from Altran, Thilo Stieber from Atos, Raymond Adam from Michael Mann. Before we start, just let me remind you, as usual, if you have any question, and all questions are good, push it to the tab, to the question tab, the specific one. Right, so without any further ado, as usual, so I would like to start with our first speaker, Conrad Gros, Director of European Field System Department from FANUC Europe, to start his presentation. Conrad, it's yours.
I think, can you hear me? Good afternoon.
Yes, we hear you. Good afternoon.
Good. So, good afternoon, everyone. Thank you very much for joining this seminar. I will talk about industrial IoT platform on example of field system. So, I will shortly introduce myself. I have 22 years of experience in industrial automation and robotics. I am a mechanical engineer and also graduated MBA student. And since 2014, I work in Luxembourg on different jobs. Recently, I'm responsible for IoT solution of FANUC, which is called Field System, which I will talk today about. My interest and skills are around automation, Industry 4.0, robotics, but also sales strategies, sales channels, selection, recruitment, and so on. I personally have one daughter and a lovely wife, and I also like jogging, golf, and sailing, but also I'm really interested in drone technology. So today, I will talk about the concept of a field system as an example of industrial IoT platform, but also I will talk about some features which are typical for industrial IoT platforms and example of applications. If you have any questions, please don't hesitate to ask on this portal, and in the Q&A section, I will answer all the questions. So I will start with the field system concept, which is the combination of four functions: connect, monitor, think, and drive. And I will explain these functions on later charts. So connect means that we would like to allow customers who are manufacturers of any material to connect all of their equipment to industrial IoT system. Today, there are systems which are existing on the market. They connect selected machines, selected equipment. We intend to let the customers to connect everything, no matter who is the manufacturer of the equipment and how old is the equipment. So we also talk about equipment which is 30, 40 years old, but is still used on the customer side. And customer would like to receive the data from this equipment and improve his manufacturing performance. Second is monitor. So this is the function which enable customers to see what is the current status of their production. Customers can see what happened in the history. Customers could understand where to focus their attention to improve their productivity, to improve their quality, to reduce the cost of energy consumption or some consumables consumption, and so on and so on. And this is the typical scope of an industrial IoT system. They enable customers to connect and monitor. We go a little bit step further. We have a function of think, which means that in our system, the software which is implemented on the field system can utilize the Tesla GPU card, which enables the developers to utilize machine learning technologies for customers to better understand the data. So, as you know, the no information is bad situation, but too much information, also overwhelming situation, is not good situation. So our system will help the customers to correlate the relation between the data and drive conclusions in a more focused way and quicker way. The fourth is the drive. So once we bring this data to the customer, or the system knows the conclusions from the data, then we can bring back these conclusions to the manufacturing floor and improve productivity in automatic way. This is our long-term vision, that we not only bring the data to the customer to take decision by human, but also in future some functions like quality management could be realized automatically in the background for customer benefit. So this is the field system. It's showing on the bottom the equipment, which could be different equipment in manufacturing process, like machines, like robots, like sensors, like whatever equipment which could gather the data. This data is coming to field system, and on the field system we could have different applications. Majority of applications will come from third-party developers, and this is my invitation to all companies who are listening now to this seminar to contact us if you would like to develop the software on the field system. This software will be placed on our store and will be sold to customers in the location which you wish. So this software could be placed just for European customers, or just American customers, or Japanese customer, wherever location you would like to sell your software via field system. We will provide a reliable and secure infrastructure for software development and software sales. This system will allow also end user customer to reduce the cost of IoT system implementation, because the software developed for one customer costs a certain amount of money. But if the developer knows that the same software can be sold to 1,000 other customers, the software cost would be lower. So we really concentrate our effort to bring applications on the market which are bringing high value for the customer in affordable price. So the concept is we start with edge heavy. So we try to analyze and process maximum amount of data close to the manufacturing. So as you know, the IoT systems, they can monitor a big amount of data, but more efficiently is to process this data close to manufacturing process and react quickly, and aggregate and send the data to other systems just when it's necessary. So this edge heavy is the first point of field system as a differentiator. And second differentiator is open platform. So as I already mentioned, we can provide software development kit to application developers who can develop the apps to increase the benefit on the end user side. So this is description that some of the data could be processed in the edge environment, and some of the data could be processed, for example, in some cloud servers. I don't have too much time. I have just 10 minutes. So the last remaining minutes, I would like to focus on the potential application software. So this is example of monitoring software. where it enables to analyze the data from connected devices, show the data in the status dashboard, or show the alarm history, and so on. And the benefit for the customer is that customer can focus on the most important situations in his factory, and customer could react to recent challenges quicker, being focused on the most important incidents. On the other hand, there is another application which is called Daily Check, which enables customers to gather the data from maintenance efforts, preventive maintenance efforts in electronic way. So this supports digitalization of factories. So today in many factories, the workers that are going around the maintenance the machines, and they collect the information about the status of the machine on the paper tick sheets. So they say this is the oil level, this is the level of some consumables, and so on. And we would like to help customers to move it towards electronic data gathering, but not only electronic data gathering, but enable the ease of use. So this system automatically detects who is the operator, who is collecting the data, in front of what machine he is standing, and so on. And this data can be utilized later for troubleshooting or preventing any potential failure. So as I said, I had just 10 minutes. So this is the just very brief introduction. To summarize, I would to say that there are a lot of IoT systems on the market, and they really develop from different suppliers. And when you select the industrial IoT platform, it's good to have a wide overview of what's currently available. So thank you very much for your attention, Marina.
Thank you so much, Konrad. Indeed, it's very concise presentation. No questions so far. I'm sure that you will have questions a little bit later. I'm going to, kickstart the question though. So you showed some use cases in your presentation. What are the typical use cases actually of industrial IoT in Europe?
So typically, customer today customers are interested in the predictive analytics for preventive maintenance. So they would like to understand based on the data collected in industrial IoT systems. They would like to understand what will be the next potential problem machine, and currently available systems, they enable customers to prevent this failure and do the preventive maintenance work on a planned production stop.
Okay.
So this is the most popular application and the most popular use case. I believe in the near future, customers will also benefit from quality management applications or energy consumption reduction applications, and so on and so on.
Thank you. So there is a question. Actually, there are two questions. I'm going to start with the first one, showing it on the screen. So how frequently do you update your AI models?
So we, as a FANUC, we don't create AI models. We work currently with 3 companies from Europe, one from Austria, and one from UK, and one from Italy. And these companies are creating AI applications for field system. And I cannot answer this question from our side. I would need to discuss about particular applications, but I don't know who asked this question, but I would be more than happy to answer this question.
Stephanie.
Stephanie.
I don't know. So sorry for for the pronunciation of the name, but you can then discuss this offline. And she has another question. Let me share it with you. So how do you share information securely between members? That is an interesting one.
So you mean to share information between members of the ecosystem or between the machines? It depends.
I don't know. Maybe between the machines. Why don't you get this answer? I mean, on the chat, and then try to answer and discuss with Stephanie through the questions, and everyone can also see the exchange. Okay. So thank you so much, Conrad. I would like to move on to our next speaker, Mathieu de Beuvrouchon. He is the Advanced Solution Manager, Digital Transformation at Altran. And Mathieu will also take us through the different possibility and the different new technologies advantage for Industry 4.0.
Okay, hi everyone. Very happy to take a few minutes to talk about new technology and trends after a big specific semester with the COVID, as you know. I'm a part of the team in charge of designing digital transformation solution, linking all the expertise of Altran in France, in Paris. And my background is quickly simple, 10 years in digital transformation, beginning by transformation of digital marketing department, and since for 5 or 6 years about transformation at scale, including different specific strategy for HR or reorganization or process management, etc. at IT transformation. I'm also the author of a book dedicated to the main tech event in the world is the CES of Las Vegas. And the author of 2 publications a year for Altran based on our analysis and our vision on the tech trends each year. So do not hesitate and feel free to ask your question directly in the chat because I have only 10 minutes, so it's not enough to talk about tech. So 2 slides to begin to give you some elements of context. First one is, since the origin of internet, we have witnessing its deconstruction. And we have now an emergence of the GAFAMI, Google, Amazon, Facebook, and Apple. We have recreated a new form of internet, and an internet in the form of winners take all philosophy, where some companies have globalized totally everything and generating today a form of mistrust in the face of what is become now that we can name a system. And the relationship to profitability has totally destabilized the market. As you know, Uber, Netflix, Twitter, Facebook transform some economies. So growth is now the norm and more important sometimes than the profitability. So traditional players are totally destabilized, and the transformation is, okay, often too slow. We know because big companies have a lot of inertia. Large player will leave them totally dead. So the COVID crisis is a good example of the capabilities for companies to transform themselves more quickly and with a lot of resilience. The year 2019 is marked by 2 different main things. And the first one is a form of distrust of the system, a loss of confidence, the enmity of power of tech, regalian or political people who struggles to arbitrate. And the second one is massive environmental awareness. We have this present for a few years, but it's sudden last year by its magnitude. All these 2 things generate a form of bipolarity of requirement for people and for the society. So when we talk about technology today, we can't associate. It's not possible to dissociate tech between resilience. Resilience is the main important. It is the major trends today to in the tech, and it's a really large. Resilience is a large definition. until 2019, resilience was sometimes associated by the notion of technology at the service of people in case sometimes of emergency. What is really interesting to note is that 2019 shows a very clear movement by most technology players to talk about environment. And tech now is mainly associated with the climate emergency and the desire to work on the long-term vision to serve the planet and to change the world. So that's a real change of philosophy, because it's not the same mindset to use technology to serve human and or to use technology to change the world. So that's the possibility or the second chance for the big players, the tech titans, to change their brand strategy. So the resilience is based on two levels of technology verticals. The first level includes the capabilities level, without which nothing is possible, as you can have the artificial intelligence, 5G, sensors, chipset, etc. And the second level, it's not less important, but it's less important instead of the fourth one, including augmented reality, mixed reality, 3D printing, robotics. Because when we talk about 3D printings, we can talk about food to print some vegetables or to print some meat today. So you can talk about resilience in a global point of view with an abstract level above all. The level of reading that you should have is more global. If we start from a vision relating to individual people towards society at scale, we can consider that the word smart based on the need to think about interoperability and interconnection of IT system. So that technology as well is invisible with regards of the service it's provide. And that's why we have to define the global visions that we want to have when we help some clients specific for industrials, to have a people view to a global view, to go from to come from people point of view to nation point of view. And when you are talking about smart nation, it's not the same complexity of ecosystem if we talk in the opposite of smart entertainment, because it's not the same complexity. And today, specific after the COVID crisis, we can consider that the new world is arrived and the transformation is now mandatory, not only on the PPT or PowerPoint strategy. The consistency between the brand strategy and the operational transposition of this strategy is clearly one of the first motivation for your employees and maybe for your clients. So you have to think global and local in the same time. That's the most important difficulty. And think interconnection, interoperability and interability of all your ecosystem, sometimes your third parts ecosystem. So to illustrate this fact, I choose one of my favorite projects since the January, because every year you have a lot of projects, but the CES of this year was really interesting, specifically to demonstrate you that major industrials people wants to have a vision of what will be the world in the next few years. The first one that you can see on the screen is a concept of city from named Woven City from Toyota. So this city will host 2,000 people on a former industrial site of Toyota. So you have the same project from Bill Gates on Belmont. You have the same project in Toronto by Google. You have a lot of projects about smart city. But this concept of smart city is clearly to define a new way to engage people or citizens in a global ecosystem. So Woven City is a prototype of the future vision of a city. The first resident will be Toyota employees, but you will have visiting scientists, industrial partners, retailer, retired people, and people, vehicles, and building. We will all connected on the same platform to communicate with each other. It is possible to try out a lot of technology on this project, as autonomous vehicles, robotics, slow mobility, or smart home, all integrate, because you have three main parts of this project. The first one is the motorized vehicles directly underground of the platform. I will show you the photo, the slow mobilities, and the pedestrians. So this is the three main pillars of this concept. Buildings mainly made of wood, roof with a lot of photovoltaic panels, intelligent interior, connected ecosystem, integrated Alexa by Amazon or any conversational agent, intelligent fridge. I know a lot of interaction between technology and human, but one of interesting things in this project is that Toyota wants to create an invisible interface between human and between the technology. So you have a real vision of the convergence between hardware and software to create a global, unique experience for human. And the last slide illustrates the global view of a utopic project, okay? Because beyond the surface of the city and the underground network will transport all the goods and all the important vehicles. So like we had the Corbusier in France few decades ago, Toyota is now following the lead of Bill Gates, Google, to create a vision of a smart city. They come from automotive and they go to the global mobility. You have the same way on Uber, for example, with Hyundai on next January. Another example is Gatebox. I don't know if you know this concept. It's typical. It's an application for Japanese people, because you can change if you want to locate your concept in another country. But Gatebox, including holographic conversational agent that interact both with you or normal human, but also with the environment. So it's able to connect a dozen of services such as I don't know, but your calendar, to send you an alert, or to discuss, to interact by text message with you directly if you are not on time at home, to start cooking a meal. So this concept is currently live in Japan with long-term impact, maybe on human relation. So that will be really interesting to analyze. I know that it's scary in our culture, but it's a good example for an industrial to create a global convergent solution between hardware and software with a lot of interaction. One of a good project is the project of Ford. Ford acquires a bipedal robot from Agility Robotics to ensure the delivery during the last few meters of delivery in dialogue with connected vehicles. So that's a good way, because the robots will go directly on the street to pick up your package and to deliver this package at home. So I think that will be good for us, but maybe my grandma will have an attack with this solution. So, but it's another example from an industrial to test some new concept to enlarge the perimeter of their expertise. BFC is one of the last projects that I will show you. That's for me a good example of a resilience solution. So it's a paper-based battery. So it's a battery made by paper to generate low power for IoT or medical device. And the concept is to replace at terms the existing lithium battery in first in medical device or biomedical device. So that's a great, it's French, and that's a new startup. Just have CS Awards in January, just fantastic. A lot of things to do with that, but I think the new version will be more better. So it's quite fine and just beautiful. And Xensio, somebody play with the presentation. Xensio is the last one. It's developed by the University of Swiss Federal Institute of Technology. And this concept is to develop a sensing platform to detect in real time biochemical information at the surface of the skin. So it's not underlying sensor under the skin, it's on the skin, and it's a non-invasive way, but very simple to have a unique capabilities to generate information about your health and wellness in real time. And that's a perfect resilience project to use when you are talking with industrials in health economy. That's for the chronic problematic of health a good solution to have some information about people. Some joke to close this presentation, because it's the tech is we have a lot of joke. The first one is the smart potato. This is nothing. This is a fake. This is only a potato with a Wi-Fi Wi-Fi plug. But that's a joke. And this person has a stand on the CES and make the joke during the 4 days of the CES in January. So that was great. And the last one is just okay, fun. It's a toilet paper delivery robot. If you lose or lost or forget your the toilet paper, this robot come to help you. That's charming. It's a big it's supported by really a big company, so it's Unilever. To finish, I did not talk you about retail, blockchain, efficiency, collaboration, 3D printing, etc. The 10 minutes it's not enough to talk about technology trends. There is a lot of fantastic things. To finish and to conclude, I like to use the symbol of a cocktail. This is a mix. If you are thinking about tech, innovation, globalization, you have to develop an holistic integration. And for that, you have the main pillars that AI treatment, different connection, 5G, etc., LoRa, Sigfox. You have the sensor, the capability of different support, the screen, etc. What is interesting is to resume this presentation in 3 main keywords. The first one is convergence. I think this is the more important things. The second one is the interoperability of different IT systems, etc. And the last one, more important, is the ontologic visions that you can have to define a new approach of governance. Thank you.
Thank you so much, Mathieu. So that was very interesting presentation. I'm going to skip the questions actually now, because I would like to give room for the other speakers as well. Anyhow, have a look on the chat if I think that will be questions, and then feel free to interact with the question directly. Thank you so much. So our next speaker, you will not see him in video. You will see only his picture. That is suspense. No, actually, he has a technical problem for the video. Nevertheless, he will be presenting to us. Thilo Stieber is the Chief Digital Officer Manufacturing at Atos. He will be talking about the digital factory, how he called it the digital decarbonized factory. So Thilo, it's up to you. You can share your presentation.
Yes.
And yes, thank you. Let's go.
Hi, everybody, and thanks for the introduction. And just a comment to Matthew, very interesting. And in January 2020, I think nobody has seen the value of this toilet paper service, especially in COVID times in some countries. Interesting. Okay, but now today, my presentation will focus on the expected upcoming new requirements for manufacturing companies with regards to sustainability, decarbonization, and energy efficiency, and how we can gain additional energy savings by applying new technologies. As stated, we believe that in the near future, especially in Europe and other countries, a lot of new regulations will pop up around the decarbonization, where manufacturing companies will give a better information, feedback to governments, to customers, to vendors about their energy consumed per part, per process. If we are looking how it is nowadays in most companies monitored, we see a typical top-down approach where companies try to control, to measure the energy consumption on a macro level, which I would say on the plant level or on an asset level. But to achieve the additional savings, and if I say additional savings, if we talk to the experts and analysts, they say independently where you are in your optimization process, there's always additional 20 to 25% energy savings if you are able to take advantage of all the data you have across your company to achieve more savings. And to come from a macro, to come to that point, I think you have to leave the macro level, just looking on collecting of data and optimizing data on plant or asset level, that we truly believe that in this view, you have to include business process information as well as information about the exact processes you apply, to be able to say what is the impact in addition of these macro elements on the process you do in your shop floor and on the part level. And that creates a couple of challenges to come to that point from a macro to a micro level. So we do see two main challenges. One is that you need more data, because most of these data are currently even not monitored, or maybe monitored in different systems. Really, to apply energy consumption on a micro level, you need the energy footprint on every single process and part you are producing in your plant. A lot of new data must be collected, managed, analyzed, monitored. And that comes to the second challenge, is as we know, especially in IT OT environments, data, the correlation of data creates a lot of efforts, especially in this environment, as stated. So that means for each new set of data you want to analyze, usually in this complex environment, you have to do a lot of things. That costs money and that costs a lot of time. And in my next slides, I would like to show you a way how we believe these two main challenges can be handled by applying new technologies. But before that, let's have a look that we see a kind of starting point. So if we are looking on how nowadays energy consumption is monitored and optimized, we see in manufacturing companies, we see a landscape of different systems. And we see also that these systems are not highly integrated, and that the data of these systems are only little correlated. So I just put one example where of 3 different systems, which might be a power management systems where you connect some assets or devices from the plant. You have, of course, the production management systems where you connect your production environment to collect data. And then usually what we also see are some smart building management solutions where you track energy consumption on a building level. And usually also seeing that on all these levels, the teams are trying to optimize the energy assumptions by starting some isolated energy consumption saving optimization ideas in each of these silos. And that leads in many times to the situation that in the production management, I'm just making an example, that the guys in the production management, we try to optimize the energy consumptions by changing the business processes, how we produce, by changing about how we would like to produce the parts, etc., etc. So we might create some energy savings in their domain, but at the same time, because there's no correlation, what might be the impact if I change a way how I produce a part, or what is the impact on my building if I change the production process and maybe the production times and etc., etc. So that means you get savings in one domain, but maybe unknown, you're creating some negative impacts in other systems. So at the end, in bad luck, you even do not achieve savings at all. You are even increase your energy consumption by an isolated approach to create some savings. And that's therefore we believe companies should move away from this silos thinking, and we should consider energy consumption as a kind of change program, to see it holistically and to avoid these negative impacts. So how to do that? First of all, we see, of course, let's say during the last years, that one try to get more insights into the data and make them accessible for everybody was a way to go to the cloud, to moving application to the cloud, data to the cloud. And in the last years, there was a lot of efforts undertaken to get to tools, methodologies, techniques to automate and to optimize the data management in cloud environments. I think this is a very important achievement, because at the end, as we stated in the second slide, the main challenges was the efforts to manage the data. So we believe that this approach is an approach to be followed. Shift all data-centric services to the cloud to gain advantage of the tools, the dynamic agility, scalability of cloud. But what we see, especially in the manufacturing shop floor environments, that the world is no longer only a cloud. We see the rise of the edge computing coming up, edge computing getting more and more powerful, and therefore more and more use cases getting more attractive for manufacturing company, where edge computing are the technology layer to enable new services because of the volume of data, because of computing power, because of latency time, because of simply not being willing to move high volume data to the cloud, which could create additional costs. So therefore, we believe, in addition to the cloud approach, where we said move all data-centric services to the cloud, we say, and now shift all real-time data-centric services to the edge. So at the end, you have to find out which kind of services should be moved where. But we truly believe that in the future we will see a scenario which will be a combination of cloud and edge services to achieve business benefits on all these levels. And that is now creating another complexity, because we are moving away from a harmonized, automated cloud environment to a more complex cloud edge environment. And how to handle now this complexity? We believe that is now the time to implement a kind of abstraction layer for cloud and edge environments. We call it as a runtime as a service, just to illustrate that we service approach from an infrastructure as a service, platform as a service, as a runtime as a service, basically providing a runtime environment for your people, developers, for new services, new use cases, people who are managing the application, to improve operations, to help to improve your real-time service development and deployment, and to help your company to optimize real-time data handling. And with this kind, with these layers, we would like to come back to the point that if you develop a new use case, if you develop a new service, that you develop it once and you can deploy it anywhere. Anywhere means maybe this service nowadays runs on an edge device because it makes sense in that specific environment, but maybe in the near future, you want to move it to the cloud. And that should be done in a smooth way without starting mass activities to deploy new services in edge to cloud, etc., etc. And I just come back to the questions I saw in the first presentation when someone was asking how often do you deploy new AI models with such a layer where you can use automated tools of deploying and managing services independently on the layer on the edge or cloud, then this question is getting less relevant because when the efforts are minimized and you can deploy much more frequently with less efforts, higher availability, new models to as a base for new use cases. And that brings me to the last basically to the last slide. Now, if I look on this yellow bar, that's for us if you have such a cloud edge data platform in place, which follows the idea about cloud and edge, plus implementing of runtime as a service layer. Then you have access to data on production, plant, asset, business process, and part levels. Even you can apply external data like from the market, especially if you think about energy efficiency. Many companies use market data, weather data, consumption data to plan their energy consumptions. With that layer, then you have the capabilities to create new use cases, which we are integrated system because the data can be easily bring into correlation without having a huge manual efforts and a long time. That makes you faster, and that gives you the platform, the base for creating or gaining the 20 to 25% energy consumptions, which are possible to achieve if we can believe the experts. That means now you have to look a little bit on the tools you need to take to turn the data into insights. We are powerful BI, advanced analytics, machine learning tools available on the market, which you can choose depending on your company preferences to turn the data into value. With that slides, I hope I could show you a little bit a way how new technology can be applied to achieve energy savings, energy consumption optimizations, which we truly believe is required in the near future, even more than today, to be first compliant with new stricter regulations, and secondly, with the expectations of your customers, of us, to be more environmental friendly than as companies have been in the past. Thanks. And now I think a few minutes are left. Maybe in case there's one or two questions, more than happy to answer.
Thank you, Thilo. Thank you so much. There are no questions from the audience so far. Interesting thing. So you mentioned something called runtime as a service. So why it's called as such? So we know SaaS, PaaS,
yes.
all this kind of new, well, not relatively new on cloud. So would you just elaborate a little bit about that concept?
Yes,
we
sure.
We don't have a lot of time, so
yes, I try to do it in two sentences. So this as a service concept was basically developed as infrastructure container. Even nowadays, feature as a service has been developed to reduce the complexity for people who don't have to know the complexity of each layer, because we are focusing on different outcomes. So with a runtime as a layer, we want to hide the complexity in terms of how to build a service, in terms of scalability, in terms of security to your people who are developing and deploying new services which are generating business benefits. So in a nutshell, hide all the complexity from people who don't have to know how to do it, to give them all the freedoms to focus their time on value-add activities which are focused on to achieve the outcomes we are looking for.
Great, thank you so much.
Thanks.
Thank you. Now, up to our last speaker, as usual. So we've heard from the first speaker about their expertise, their knowledge, how they can support your companies. But now we are going to hear from Raymond Adam, Laboratory Manager, EMEA at Michael Mann. So Raymond is not going to talk really about a real implementation of IoT. It is very interesting what he is going to present us. He is going to talk about how in a global company, R&D department should cooperate to bring these solutions to be a digital factory, right? So a little bit what is going on behind the scene.
Hello, everyone. Thank you, Marina, and thank you to Lux Innovation for having me today and giving me the opportunity to present this case study on the theme of how Michael Mann aligned its innovation structure towards a digital factory. Before I kick off with the theme, let me introduce briefly who we are. Michael Mann is a family-owned company business in its third generation of founders and owners. We're headquartered in Cincinnati, Ohio. We have offices, R&D, and manufacturing facilities around the globe, and we are present in America, Europe, India, Singapore, and China. The products which we manufacture comprise water-based emulsions, which enter into the composition of formulated coating products to protect surfaces such as wood, as you can see in the picture on the left, but also on metal to protect against corrosion, and on concrete and walls for protective and decorative paints. The second business, which we call industrial manufacturing, develops emulsions which can be used to coat glass or carbon fibers to make them adhere to the polymer matrices in which they sit to make tough and lightweight composite materials. Those are used in the aerospace and automotive sector. And the third business segment is about coatings for the printing and packaging applications. In that segment, for example, we develop primers that are coated on paper and plastic to optimize for ink adhesion, so they become printable, and other products add specific functionalities to paper and plastic foils, such as, for example, oxygen and water vapor barrier, so that the food packaged inside those materials lasts longer on the shelf before it's being consumed. Maybe a few words on myself. I'm part of the EMEA extended leadership team, and as such, I'm the contact person for all technology-related matters in the region. And more related to this case study today, I was on the core design team that specified the digitalization of our global innovation process, and then later was affiliated with implementing and managing the process for our development, specifically in India and in Asia. Next slide. Michael Mann has a staff of about 400 associates, out of which 50 work in R&D. So the focus of this presentation and case study is on international R&D teams delivering products either to single customers or markets. And Michael Mann, our local research teams are spread out over the globe and are being tasked to solve different challenges. What are those challenges that exist in the businesses? Let's take an example from the printing and packaging segment, which I introduced on the previous slide. Think about the issues around non-recyclable plastic waste. Many countries on the planet today still lack organized systems for management of plastic waste, leading to widespread littering and landfills. And also at the same time, legislation is being passed to address those issues and accelerate solutions. So think, for example, the EU's Green Deal, think the Single-Use EU Plastics Directive, and now also India is banning single-use plastic items, and that will become fully effective by 2025. So on our side, by developing, for example, coated film and paper materials, these packaging structures can become recyclable and enter waste streams for recycling rather than go to landfill. Let me now talk a bit about the R&D model which applies, and I've borrowed this model from Ted Farrington at the IRI. to explain in which environment we are on our or in the journey to globalization. In general, companies that produce in different regions have traveled across a few phases. Many started out from functions working in isolated silos, then shared information across regions, established intra-company collaborations, and some reached a situation of interdependence of teams across the sites. Typically, a company that runs independent silos supports local businesses, is self-sufficient in the sense the R&D teams operate, doesn't share much information across campuses, and may also operate different processes, for example, product portfolio, management systems, stage gate, and others. So there's a lot of redundant activity. In a collaborative environment, teams are still self-sufficient. Some interdependency exists. Sometimes products are co-developed on an opportunistic basis. Difference of IT systems may still prevail, but there is less redundancy across the region. And in an interdependent model, every campus is dependent for the success of the projects, what the others contribute as well. So work in progress is and must be visible across the regions. Also, the IT tools and processes must be compatible. Workflows, approval processes must be harmonized. And this all leads to more efficient use of resources. So the more you move from the left to the right, the more information must flow rapidly. And this is where digitalized processes, I think, play an important role to connect R&D with their global groups within and with the factories. So in my view, the R&D organization at Michelmann currently sits between the collaborative and interdependent stage. What have we done at Michelmann to digitalize the innovation process? The concept of phase development for new products is not necessarily new and exists since many decades. Those development processes generally consist of a certain number of phases, as shown on the top slide, and those are separated by periodic reviews between phases. I believe the term stage gate has already been coined by Robert Cooper in the 1980s, and the traditional stage gate process is including from the beginning to the end the efforts around scoping, developing a business case, testing prototypes, scale up, and product launch. So in our case, the contact points where our R&D teams meet with the factories typically occur during prototype manufacturing, particularly at larger scales when the quantities produced in the lab are not big enough anymore for the customer, then during the scale up at the plant, and the final handover to manufacturing at the end of the development. And also field testing at the beta customer site is another contact point between R&D and the factories. So in our case, the strategy to digitalize a product development process already relied on a robust methodology as a foundation. Besides this process to digitalize, we had existing tools. We had a well-established legacy ERP, a new CRM tool, which at that time was in its last phases of implementation. We had a technical project data repository and also a regulatory compliance software. So all of those existed and they needed to be somehow considered. The digitalized new product development process then carried relevant project information such as the project charter, business case information, financial documents such as NPV calculations, and obviously project status updates. On top of that information, this then was allowed us to use this input for portfolio management, make dashboards, and generate sets of KPIs. On the next slide is a bit the timeline to help you understand what we did. Back in 2018, the approval and support from the with the approval and the support from the executive, a core design team that consisted of representatives from marketing, technology, and operations sought input from the users and their needs. It also frequently reported back to the executives. The first digitalized version of the process was deployed at the back end of 2018, and we had multiple training sessions which were customized to the various audiences. For example, we had a general overview training to announce that the changes were coming, and then those were followed by more in-depth function-specific trainings, for example, for reviewers, project leaders, and approvers. In 2019, development deployment continued across the region. We did that for Europe, India, Singapore, and Shanghai. The members of the core design team also acted as process stewards, so they assisted the teams to enter all the projects in the system, and then had teams and businesses to operate them, coaching everyone, all stakeholders along while they were using the system. And now in 2020, where the system is running, we collected user feedback in the form of individual interview sessions, so with the intent of making continuous improvements to it. So this brings me to the last slide of my presentation, where I tried to put together the lessons learned of our digitalization project. So first, on the theme of aligning the infrastructure to the strategy, I believe it was critical to involve all the stakeholders in the process design from the beginning: technology, sales and marketing, but also regulatory, procurement, all participated. We had the buy-in from the business for the undertaking, and the executive support that was important. It also occurred that we were redesigning parts of pre-existing bits of processes for parts which didn't add value or became redundant. And as I said before, user training and coaching was critical. On the system side, on the downside, the missing integration of IT tools and business process automation remains a hurdle even now. It slowed down the adoption by the users. I understand there are solutions offered from software companies to allow data flow between large IT systems, ERP, CRMs, and this is still on the priority list of us in terms of improvements to make. And particularly, we felt that we needed streamlined automated workflow approvals, also to ensure a good adoption of the digitalized process by the users. And then in the second row, on the theme of developing and leveraging expertise, a digitalized system in a global R&D organization is another means for the associates to establish the trust in this digital environment. It's this process which we put is a conduit with which the associates can interact with other audiences in the company, within R&D, but within other functions. And they can position themselves as thought leaders or experts in their field of expertise. And that's beneficial for associates' engagement. It's beneficial for their satisfaction, as they feel that their contribution is seen and valued. And then in the last row, on speed, developing fast, one of the advantages of StageGate that is often heard is that the gates help make decisions, go or no go, but certainly they ensure on the positive that the resources are spent from the company on projects that really matter. The systems and tool side allows us to install KPIs and dashboards, so progress is clearly visible, or if it doesn't progress as expected, corrective actions are called, so projects do get the attention from the business leaders. So on the people side, I would say even with the proven methodology, the data being available to make decision-based decisions in the gates with risks of projects well assessed, even a digitalized process can have faults and drawback because project complexity is there, multitasking prevails, there's daily workload, and perhaps beliefs and biases may also interfere with the decisions. So these were a bit, in summary, the learnings of this digitalization process. Before I hand back to Marina, maybe just if I can conclude on a final comment that this digital transformation for us was certainly a bit of a technology change, but also, and perhaps much more so, a human change rather than just a technology change. So the soft skills and the change management in this project were clearly vital to the success. So with that one, thank you very much, and back to you, Marina.
Thank you very much. That's true. It's not only about technology, it's about technology, human process, change management, client experience, and actually all what we've been discussing since the beginning these talks. But very important. Actually, I have a question. It's interesting the way that we are discussing prototyping, right, and the importance of R&D works to bring a factory to be a digital factory, smart factory, use more technologies. Would you be able to share with us some example, for example, about projects for which you've been going through R&D on digitalization, of course? Was the results was as by your expectation? So if you can share with us some best practices or some expertise on that one. It's always important to hear from the people who are doing it, actually.
Okay. So the question, let me say the process of product development is a digital one, and then the product development itself brings with it to physically make products and ship samples to customers and have them evaluated. The digital part certainly is with the factories that at the end they will get a bill of material, they will get a set of specification, instructions, maybe raw material specifications, so they will get digital information to that. So what helps is there's certainly a solid ERP within the company that helps handle those in a reliable form. So that's a pillar, I would say, of producing in the industry that needs to be done. And the new product development was a separate process on top of these. I introduced the other processes that we had, and they are a must for the industry.
Okay. And then, in your opinion, because you have your production is very specific, it's material and it's kind of chemical, right? So in a post-COVID-19, what would be the tool of digitalization processes from which an R&D would benefit, or even another organization, actually, or manufacturing organization?
In the COVID-19 period we're in, as many companies have taken measure to prevent contact between employees and have only essential folk present. And I would say in a post-COVID area, that could still going slowly. And R&D, when I look at R&D, needs to or wants to know how does the samples perform at the plant, at the customer. We've got dedicated staff, field engineers who accompany our products and visit customers. So that could be slowed down. If we could have digital glasses or cameras that would film on site what is going on, how products perform on the customer's line, and then in real time we could over distance be part in real time of the test, that would be certainly much beneficial given the current circumstances. So any tools in that area would be a big benefit.
And that's exactly what we wanted, really, to show that how important the use of this kind of technology is, not all the time, but probably for really particular moments or particular need or situation. Okay, thank you so much, Raymond. Thanks to everyone. Let me share with you what we are going to see and to do next week. Next week is our episode number 9. This is really the last one of this first edition of the L-DIH talk. So we're going to talk about how to use this data, what to do with this data, actually. And yeah, so we are here, as I mentioned. So today we've been talking about moving toward a digital factory, and next Thursday we will be talking about how to use these available data. There are tremendous all kind of information in a factory that the company or the industrial company can get and use to take the right decision or the right activity. For this, I will be welcoming next week. So Philip Conan from Stremler AG, Yannick Bruck from Fujitsu Luxembourg, Benjamin Hurt from EarthLab, and Fabien Lepons from IEE. So looking forward to see you next week. Big thank again to all the speakers in this today talk, and hopefully we'll see you next Thursday. Thank you so much. Bye-bye.